Welcome to Bandwidth 10. We are happy to present you our cutting-edge tunable laser solutions. Let's start. The company Bandwidth 10 was founded in February 2011 from a team out of UC Berkeley and industry veterans, all professionals with long experience on VCSEL and semiconductor design and manufacturing. Bandwidth 10 counts about 70 employees worldwide, 30% of them with more than 10 years experience in optoelectronics and semiconductors. 11 of them are PhDs from top American, European, and Chinese universities. Our headquarters and design center is in Berkeley, California. Operations are distributed between Berkeley and San Jose in California, and Zhongli in Taiwan. We manufacture in North America and Asia, and we recently opened a new fabrication and packaging facility in Taiwan, with a VCSEL wafer capacity of about 100 million lasers per year. To support our customers in the strategic regions, we have sales and application engineering teams on the ground in Europe, China, Taiwan, and USA. A team of professionals with extensive experience on VCSEL and semiconductor is guiding Bandwidth 10 along our amazing mission to innovate the high-tech laser environment. Phil Worland joined Bandwidth 10 as Chief Executive Officer after more than 35 years dedicated to management of optoelectronics products. Mike Huang, Chief Operation Officer, and Chris Chase, Vice President of Engineering, worked on the development of our VCSEL design and founded the company in 2011. Carlos Mateus is leading research and development and counts more than 20 years experience in VCSEL and MEMS design. We have specialized commercial and technical teams for international regional support. Our teams highly value close interactions and cooperation with our customers. At Bandwidth 10, we have a clear mission. We aim to improve quality of life and safety by enabling widespread implementation and integration of compact tunable VCSEL technologies for sensing, imaging, healthcare, and communication. We have a very ambitious vision that motivates us to make our inventive technology successful. Bandwidth 10 will become the world leader in high-performance tunable VCSEL design and hyperscale manufacturing for the consumer, industrial, and medical environments, both in the physical reality and in the augmented, virtual, and meta realities. Bandwidth 10 is bringing revolutionary VCSEL technology to the market, delivering cost-effective tunable solutions that are out of reach with conventional technologies. Bandwidth 10's VCSEL design is based on the innovative and patented high contrast grating. The high contrast grating is an electrostatic MEMS added to the VCSEL by monolithic growth and integrated fabrication process. It works as output mirror, and its position, controlled by voltage, selects the lasing modes by changing the laser cavity length. The integrated design guarantees a fast and continuous wavelength tuning, the so-called sweep. Bandwidth 10's high contrast grating swept tunable VCSEL is designed on a flexible platform that allows to obtain wavelengths from 720 nanometer to 1700 nanometer, using gallium arsenide or indium phosphide as base semiconductor material to target the blue or the red edge of the possible emission range. With a leading-edge tunable VCSEL design, optoelectronic packaging, and control electronics teams, Bandwidth 10 offers complete solutions for the laser ranging from TO and TOSA packages to swept source devices and control electronics. Our company is vertically integrated and controls each step from semiconductor design and processing to all the different phases involved in the design and manufacturing of the VCSEL chip, packaged devices, subassemblies, and modules. We define and implement the recipes and control the results and the performance in an internal process loop that guarantees the full control of each single parameter and feature of the design VCSEL. This includes, of course, the high contrast grating MEMS design. To guarantee the thermal stability and allow proper electrical coupling of the packaged VCSEL, the VCSEL chip is mounted on a thermoelectric cooler, and other electronic components are included. The standard package can be a TO-CAN or TOSA assembly. These are ready to be integrated into an electronic circuit. The TOSA assembly also includes an isolator. Bandwidth10 recently introduced in its portfolio a sweep source module for optical coherence tomography. The proprietary design is based on our VCSEL and includes an optical amplifier and the driver electronics. Bandwidth10 provides cost-effective, tunable optical devices featuring small size, low power consumption, and built-in wavelength stabilization. The company's VCSEL range in wavelength from 720 nanometer to 1700 nanometer to address many different applications. Our standard VCSEL products are now available at 1654 nanometer, 1550 nanometer, around 1400 nanometer, and 1300 nanometer, and at 1060 nanometer. More wavelengths could be available on demand. All our VCSEL are single-mode, swept-tunable up to 500 kHz, mode hop-free, and some of them can be modulated up to 10 gigabit per second. The standard VCSEL device is packaged as TO-CAN, Pigtail TO, or TOSA. A thermoelectric cooler is included in each packaged unit to guarantee thermal stability. Chips on sub-mount are available on demand. Our recent portfolio addition is an OEM swept source device for OCT applications at 1060 nanometer, with integrated optical amplifier and driver electronics. We offer control electronics to simplify the early use and characterization of our VCSELs in a laboratory test environment. All our VCSELs can be continuously tuned up to a speed of 500 kHz. The available tuning range depends on the center wavelength. For VCSEL based on gallium arsenide, the tuning range is generally wider than for indium phosphide ones. The commercial product at 1060 nanometer, for example, is a gallium arsenide VCSEL and today has a tuning range of 50 nanometer. 1550 nanometer and 1654 nanometer VCSELs are based on indium phosphide, and they feature respectively typically 10 nanometer and 4 nanometer tuning ranges. An improved version of the 1550 nanometer VCSEL has been released this year with an extended tuning range of 20 nanometer. We are working on improved designs to extend the tuning range and enhance the performance for all wavelengths. Our VCSEL is very cost-effective, best in class for power consumption, and presents itself as a very competitive technological solution for many applications. Our firstborn, the 1550 nanometer, is Telcordia qualified, which is the most demanding certification for reliability and durability. All the other designs are directly or indirectly derived from that one. We have our own fabrication facility and manufacture our lasers using our proprietary process. This guarantees full control on requirements and quality, no constraints on volume ramp-up, and the possibility to get access to custom features available on demand. This table shows some of the possible target applications for our VCSEL. Just to mention some of them, our high contrast grating swept tunable VCSEL can be effectively used for ophthalmology and ocular diagnosis through swept source optical coherence tomography, biosensors, for example for continuous glucose monitoring, vascular diagnosis, skin cancer diagnosis, blood oxygen saturation. 3D industrial sensing for real-time process control, quality check, additive manufacturing. 3D sensing in consumer electronics, augmented reality and virtual reality. Fiber Bragg grating sensing and distributed fiber sensing to monitor strain, temperature, and vibrations in infrastructures, wind turbine blades, railways, mining and fracking process, and in industrial production lines. Industrial and environmental gas sensing for different gases, for example, carbon monoxide and dioxide, hydrogen cyanide, acetylene, hydrogen sulfide, methane. Metrology, FMCW LiDAR and short distance range finders for robots, automated warehouses, and drones, and optical communications. We show here some examples of typical absorption wavelengths for common biosensing, augmented reality, and virtual reality applications. All of these wavelengths are addressable with our single-mode sweep tunable VCSEL. Low power consumption and vertical emission enable next-generation integrated portable biosensors and augmented reality virtual reality devices. These wavelengths are eye-safe. A very good example of mainstream application for our 1550 nanometer VCSEL is fiber Bragg grating sensing, also called FBG sensing. Sensors based on the FBG principle use a grating written on a fiber as sensing unit. The grating acts as selective mirror for a specific wavelength. One possible technique to use this sensor is to sweep tune a laser and inject in the fiber a train of different colors in the time domain. Since the reflected wavelength or color depends on the grating pitch, temperature changes or strain that expand or shorten the grating will shift the color of the reflected wavelength towards the blue or red side of the injected spectrum, depending on the direction of the deformation. The color shift gives a measure of the geometrical change for a specific sensor. Typical fiber grating sensing application is monitoring of stress, bending, torque, impact, expansion, deformation, torsion, vibrations, temperature, and so on, of infrastructures, aerospace elements, engineered materials, various mechanical elements. FBG sensors are used, for example, to measure the deformation of wind turbine blades, expansion of gas pipelines, deformations and vibrational modes in infrastructures like bridges, and thermal expansion of train rails. Our single-mode 1550 nanometer VCSEL is Telcordia qualified, is best in class for power consumption, and has an operating temperature from -5 degrees Celsius to 70 degrees Celsius. All these features are available at a very competitive price. Bandwidth-10's tunable VCSEL are cost-effective light sources for gas sensors based on laser absorption spectroscopy. In this application, a spectrometer measures the energy absorbed by a gas at a certain wavelength, and the type and amount of gas can be identified depending on the wavelength and the absorption rate at that specific wavelength. Wide tuning range and low power consumption enable next-generation and handheld gas sensing applications. Fast tuning speed benefits real-time monitoring. The availability of different commercial center wavelengths and possible addition of custom ones allows to cover a wide range of absorption lines. Swept source optical coherence tomography, also called swept source OCT, is based on optical frequency domain reflectometry featuring a wavelength swept light source. Swept source OCT has several advantages over the conventional time domain OCT system, such as high imaging speed, high detection sensitivity, and signal-to-noise ratio. The widespread use of swept source OCT devices for medical diagnosis in ophthalmology and dermatology has been strongly limited so far by the very high prices of the required laser source. Bandwidth10 offers a cost-effective solution and makes the technology available for implementation and use in affordable yet high-performance diagnosis devices. The compact size, together with the top emission typical of the VCSEL and the lowest power consumption, enable the future integration in portable, handheld devices. Bandwidth10 has demonstrated this first swept source device for next-generation optical coherence tomography at BIOS 2022 in San Francisco. The system was based on our 1060 nanometer VCSEL with a tuning range of 60 nanometer, and the demonstration was performed in cooperation with the National University of Taiwan. The device included a key clock and an optical amplifier with 15 dB gain, which allowed for 40 milliwatts of output power. A scan speed of 200 kHz A-scan was used to acquire the image. The scan depth was 12 mm. Our commercial swept source at 1060 nanometer is available with 30 nanometer or 50 nanometer tuning range and features output power of 20 milliwatts and K-clock option. It is the ideal swept source for biometrical applications and industrial OCT, medical imaging, optical sensing, biosensing. Besides the high contrast grating VCSEL, Bandwidth10 manufactures also distributed feedback lasers for telecom applications. Bandwidth10's DFB lasers are designed for 25 gigabit per second operation over commercial, extended, and industrial temperature ranges, and they are available in 6 wavelengths: 1270, 1290, 1310, 1330, 1350, and 1370 nanometer. They feature low threshold current optical output power of 15 milliwatts and hermetic facet coatings. Typical applications are data center optical interconnects, fiber to the home, access, metro, and transport. Thank you very much for your interest in our technology and our product. For more information, you can visit our website and contact our sales at the addresses indicated for your region.